Cranes, they're not just construction tools, they're some of the most powerful machines ever built. From land-based giants to offshore behemoths, here's 15 of the biggest cranes in the world. Let's start with number 15. So the Liebherr LTM 11200-9.1, that's a catchy name, is a telescopic mobile crane that holds the title of the world's most powerful of its kind. Manufactured by the German company Liebherr, this 9-axle crane is a staple of heavy lift operations across the world in wind energy, infrastructure, and industrial sectors. Now, the primary distinction lies in that impressive combination of telescopic boom length and lifting power, all in a wheeled configuration. It can lift up to 1,200 metric tons and features a telescopic boom that extends to a maximum of about 100 meters, that's 328 feet. With the addition of a lattice jib extension on guying systems, its reach can be further extended to over 188 meters or 617 feet, which allows it to service tall structures like wind turbines. Now, unlike crawler cranes, which have to be assembled on site and can't easily move once constructed, this one's designed to be driven to a site under its own power. The vehicle itself is a massive machine. It's supported by 9 axles, all of which are capable of steering and several of which are powered. Its gross weight, including the carrier and superstructure, can reach up to 108 tons during road transport, depending on local regulations. A key feature of this thing is the Y-guying system, a support frame that increases the lifting capacity of the boom by reducing any lateral movement and spreading out the load stress. This innovation does enable the crane to tackle more demanding lifts while maintaining stability. It's a critical addition when dealing with tall wind turbine components or heavy industrial equipment. It was first introduced in the mid-2000s and it remains in production and continues to evolve through software upgrades and mechanical refinements. And despite being road-capable, deploying it is not a quick operation. It requires several days to set up, especially when used with its full jib and counterweight configuration. Setup is typically managed by a specialized crew trained on Liebherr proprietary systems. The versatility, range, and capacity of this thing has made it a workhorse, even as newer cranes with higher capacities in stationary or crawler formats have emerged. Number 14. The Sarins SGC250. With a catchy name like the Sarins SGC250, more commonly known as Big Carl, it's the largest land-based crane ever constructed. It was developed by the Belgian heavy lift company Sarins and introduced to the public in 2018. This enormous ring crane was designed to address extreme lifting needs, particularly nuclear power plants and industrial facilities that require lifting pre-assembled modules weighing thousands of tons. Big Carl, as it's known, has a maximum capacity of about 5,000 metric tons, which places it at the top of all terrestrial cranes by capacity. The main boom can extend up to 160 meters or 525 feet, and it can lift heavy components to a maximum height of 250 meters or 820 feet when combined with its jib. It operates on a ring-shaped track, 48.5 meters in diameter, which allows it to rotate a full 360 degrees while maintaining stability under load. This circular foundation spreads the crane's load out evenly, preventing any ground pressure from becoming a limiting factor. It's classified as a self-propelled ring crane, meaning that it can reposition itself along its track without any disassembly. It was first deployed at the Hinkley Point C nuclear power station in Somerset, United Kingdom, and there it was used to lift prefabricated reactor components, some weighing over 1,500 metric tons. By using Big Carl, contractors were able to reduce the number of lifts and assembly operations required at height, improving their safety and speed. One cool feature is the modular ballast system. This crane uses up to 4,000 tons of counterweights stored in containers that can be adjusted depending on the lift radius and load weight. That modular design facilitates its transport too. The crane is disassembled into container-sized modules, shipped by truck or sea, and then reassembled on site. The entire crane is operated remotely from a high-tech control cabin located on the rotating superstructure. Operators have access to real-time data feeds, load moment indicators, wind sensors, and video monitoring systems. Sarins has said that Big Carl was engineered with the future in mind. As infrastructure projects trend towards prefabrication and modular assembly, the demand for these kinds of heavy lifting ultra capabilities is increasing. Nuclear plants, offshore wind platforms, chemical refineries, even space launch are candidates for its service. Despite its enormous size, Big Carl is designed to operate with a relatively small on-site crew. Number 13. The Zoomlion SEC32000. With a name like the Zoomlion SEC32000, it's gotta be the largest crawler crane ever built by China, and it ranks among the most powerful cranes in the world. Designed and manufactured by Zoomlion Heavy Industries and Science and Technology Company Limited, this machine was introduced in 2020 as a solution to China's growing demand for ultra-heavy lifting capacity. It's got a maximum capacity of about 3,200 metric tons, placing it in the same elite class as the world's most capable land-based cranes. It is a crawler-type crane, which means it's mounted on two large track platforms that distribute its enormous weight and allow it to maneuver across a job site. The crane was specifically designed to accommodate China's rapid expansion, especially in energy and infrastructure projects. It's got a modular design, of course, allowing its massive components to be broken down into transportable segments. Once on site, the crane is reassembled using a smaller crawler or assist crane, a process that takes about 2 to 3 weeks, depending on the configuration. The main boom of this thing can reach lengths exceeding 100 meters, with the ability to attach a luffing jib or a wind-powered jib for specialized tasks, but in total, the lifting height can exceed 160 meters or over 525 feet. In terms of counterweights, it employs a central ballast and superlift counterweight configuration, which helps balance the loads along that radius. Its control system is fully digital and provides real-time telemetry. Multiple safety redundancies are built in to ensure operational stability under high wind loads and variable environment conditions. A major debut of the crane happened in 2021 during a petrochemical expansion project in China's Jiangsu province. The crane was tasked with lifting a single 2,000-ton reactor vessel, which required precision and tight compliance with margin of error tolerances under 2%. The operation was completed successfully and was widely reported in domestic press as a milestone in Chinese heavy lift engineering. Despite its massive size, though, it's engineered to operate with reduced noise levels and fuel consumption relative to its lifting capacity. This was part of a broader push by Chinese manufacturers to create green heavy machinery that meet domestic regulatory requirements. While its international deployment remains limited compared to Western-made cranes, this one is considered a flagship for China's domestic industrial capability. Number 12. The Terex DMAG CC8800. That is kind of a cool name, the Terex DMAG CC8800. This is one of the most formidable crawler cranes ever built, recognized for its enormous capacity, dual boom structure, and versatility in ultra-heavy lifting applications. Manufactured by Terex, originally known as DMAG, the crane is an upgraded version of the widely used CC8800-1, fitted with a twin-boom system that increases its lifting power. It's got a maximum capacity of about 3,200 metric tons, placing it among the top-tier land-based lifting machines. This twin-boom design allows the crane to handle heavier components at greater heights and radius than the single-boom counterparts. The crane's base is a crawler system, which provides a stable and mobile platform capable of maneuvering on job sites without needing disassembly. The footprint is pretty large and requires a carefully prepared working pad, especially for high-load applications. But despite its size, it's designed to be modular, meaning that it can be disassembled, transported, and reassembled. One of its notable features is the super lift system. This is a counterweight carriage that moves on a trailing platform to optimize balance during lift. The system can carry up to 1,900 metric tons of counterweight, which is critical for maintaining its stability when lifting loads at extended boom lengths. It supports a variety of these boom configurations. It can be outfitted with a main boom up to 108 meters long, and a luffing jib for angled lifting, and even a wind turbine boom kit, which is specifically engineered for tall and narrow lifts like wind tower nacelles. These configurations allow it to reach lifting heights of over 240 meters or 787 feet. This crane has been employed on certain high-profile energy projects worldwide. In the Middle East, it's been used for petrochemical facility construction, lifting prefabricated reactors and tower sections. In Europe, it's assisted in nuclear power station assembly, and in Asia, it's played a role in port expansion and wind energy installations. But one of its biggest achievements was in 2012, when the crane lifted and placed a 1,500-ton steel absorber tower in a refinery complex, one of the heaviest single-component lifts in the region at that time. That entire operation required planning and software-based modeling and real-time monitoring of environmental factors like wind speed and ground pressure. But from a technical standpoint, it includes advanced controls and diagnostics, and operators can monitor the lift via multi-screen consoles and a pressurized cabin located on the rotating upper structure. The crane is equipped with electronic sensors that track load weight, boom deflection, tilt, and hydraulic system pressure. Only a small number of these cranes exist, primarily operated by leading heavy lift contractors like Sarins and Memoit, but because of its limited production and ultra-specialized applications, it's rarely idle. It's typically booked for large-scale industrial projects years in advance. This thing does represent the pinnacle of twin-boom crawler crane design. Its combination of strength, modularity, and precision makes it one of the most capable and respected machines in the global lifting industry. Number 11. The Memoit PTC 200DS. Another name that rolls off the tongue, the Memoit PTC 200DS, is one of the largest and most advanced ring cranes ever constructed. It's operated exclusively by Memoit, a Netherlands-based global leader in engineered heavy lifting. This one stands out though for the extreme load capacity and modular construction. It's able to perform multiple lifts without repositioning, critical for congested spaces or space-limited worksites. This one belongs to the PTC or Platform Twin Ring Containerized series of cranes. As the name suggests, the crane is supported by a twin ring base, a massive circular track that allows the crane to rotate 360 degrees. This ring base spreads the crane's weight out over a larger area, reducing any ground pressure and enabling the crane to lift up to 5,000 metric tons. Every part of the crane, mast, boom, counterweights, and hydraulic systems, are designed to fit into standard shipping containers. This allows it to be transported to virtually any location with port and road access. Once it's delivered to a job site, it's assembled by a specialized crew over the course of about 3 to 6 weeks, depending on the configuration. It's got a maximum boom length of about 140 meters, and the jib extensions allow it to lift heavy modules exceeding 200 meters. Now, the crane's variable superlift ballast system enables it to change the counterweight radius mid-lift, which is essential when operating within tight spaces or lifting over obstructions. It's been deployed in oil refinery expansions, LNG terminal construction, offshore platform fabrication yards, and major port developments. One notable deployment was in Kazakhstan at the Tengiz oil field, where it lifted modules exceeding 3,000 metric tons. Those lifts required a level of precision measured in millimeters, despite wind and thermal expansion factors. During operation, telemetry from hundreds of sensors feed into a central control unit which alerts the crew to any anomalies or safety thresholds being approached. A backup system that ensures the crane can be brought to a safe stop in case of an emergency or failure. Despite its size though, it has been engineered for efficiency. It can rotate a full 360 degrees with a heavy load on the hook, enabling multiple picks from different quadrants of a job site without repositioning the base. With only one of these in existence, it remains in high demand for high-stakes, high-value projects around the world. Memoit's ability to move, assemble, and operate this crane efficiently has positioned it as a key player in the global heavy lift industry. Number 10. The TYSON. I know this one, the TYSON. It's a fixed gantry crane located at the Yantai Raffle shipyard in Shandong Province, China. It holds the Guinness World Record for the heaviest lift ever performed by a crane, 20,133 metric tons. That record-breaking lift was completed in 2008, and it involved the vertical installation of a semi-submersible oil platform deck. No other crane has surpassed that capacity as of 2025, making TYSON the single most powerful lifting device ever constructed. Now, the gantry of the TYSON spans about 120 meters, and it consists of 2 massive steel towers connected by a horizontal bridge girder. This system operates through 18 winches, each with high-capacity wire ropes that work in unison to hoist loads with precision. These winches are synchronized through a centralized digital control system, which allows for coordinated lifts with accuracy down to the centimeter. One unique feature is that this thing is not mobile, but the size and integration into the shipyard make it a purpose-built tool for reducing risk and time during offshore platform construction. Traditionally, platforms are assembled in modules and then joined at sea, where ocean conditions can complicate and delay installation. TYSON allows for the entire platform, topside, weighing thousands of tons, to be assembled on land and then lifted in a single complete operation before launch. This single lift method improves the quality control, reduces the labor, and minimizes the risk of any weather-related delay. In addition to that world record, it's completed multiple lifts in the 12 to 17,000 metric ton range, mostly involving oil drilling rig decks and hull modules. Each lift eliminates the need for offshore welding and alignment, which would otherwise require floating cranes and extended work on the sea. TYSON's design and construction were led by a joint engineering team from China and Singapore. It took several years of design and fabrication, and the total cost of the crane hasn't been publicly disclosed. However, given the scale and materials involved, it's considered one of the most expensive systems ever created for a single site. And while TYSON is not transportable and therefore doesn't compete with any crawler or ring cranes in terms of flexibility, it does offer a specialized advantage. It's the only crane that can reliably and repeatedly perform single lift installations of full platform topsides at weights beyond 15,000 metric tons. Number 9. The Cockhams Crane. The Cockhams Crane, interesting name, was once the largest gantry crane in the world, towering over the Cockhams shipyard in Malmö, Sweden. It was built in 1973 by the German engineering firm Krupp. The crane had a lifting capacity of 1,500 metric tons, and it stood about 138 meters tall, with a span of 174 meters. This thing was a symbol of Sweden's shipbuilding prowess during the Cold War era, which dominated the skyline of Malmö and served as a critical component in the construction of tankers, warships, and container ships. The crane's main beam was supported by 2 massive legs, each riding on rails embedded into the shipyard floor. This allowed the crane to move lengthwise over the dry dock, positioning itself over the ship hull to lift and place massive prefabricated components. However, by the 1980s, global shipbuilding had shifted eastwards, and Sweden's shipbuilding industry faced decline due to international competition and rising labor cost. The Cockhams shipyard gradually reduced operations, and by the 1990s, large-scale ship production had ceased. The crane was left standing but unused, a reminder of an industrial era that had come to a close. In a controversial move, the crane was sold in 2002 to Hyundai Heavy Industries in Ulsan, South Korea, for a symbolic price of $1. The sale sparked public outcry in Sweden, not only because of the low price, but also because of what the crane represented: a loss of industrial identity and national capability. After the sale, the crane was dismantled over the course of a year, shipped to South Korea, and reassembled at their shipyard, where it became part of one of the world's largest shipbuilding facilities. In South Korea, the crane was renamed the Hammer of Hyundai, that's a much better name, and was integrated into large-scale production lines for tankers, container ships, and offshore rigs. Although Hyundai has since built even larger cranes there, and the former Cockhams crane remains in use and continues to be one of the most distinctive gantry cranes in Asia. This crane's unusual journey from Europe to Asia made it a symbol of global industrial shifting. In Sweden, it's remembered as the Crane of Tears, a name coined by Swedish media to reflect the public's sense of loss. In South Korea, it's viewed as a valuable and functional addition to a thriving industry. It continues to operate at Hyundai's dry docks, lifting large ship blocks with the same mechanism originally designed by Krupp engineers over 50 years ago. The reliability and structure after decades of use are an example of the original engineering quality and the precision with which it was dismantled and reassembled. Number 8. The XCMG XCA1600. With the amazing name of XCMG XCA1600, which pretty boring name, is the most powerful of all-terrain cranes ever developed in China, and it represents a major milestone in the global crane manufacturing industry. This 9-axle mobile crane was introduced in 2021 with a capacity that places it at the top of its class, 1,600 metric tons. It was designed to compete with the likes of Liebherr and DMAG on the international stage, and it's quickly become a major asset in wind power installation. Unlike crawler cranes, which require complex assembly and disassembly procedures on site, all-terrain cranes like this one are designed to be road mobile. It can travel under their own power. The XCA1600 achieves this with a 9-axle chassis, equipped with multiple steering and drive modes, allowing it to navigate tight urban work zones and uneven terrain. One of the primary uses for it is the installation of ultra-large wind turbines. As wind power infrastructure continues to scale up around the world, then the cells and rotor components being lifted often exceed 100 metric tons, and they have to be installed at heights of over 100 meters. This crane was designed with that in mind. Its telescopic boom can extend to 92 meters, and with lattice jib extensions, it can reach a working height of 160 meters, placing it among the tallest all-terrain cranes in use. To handle those extreme conditions, it's equipped with a superlift counterweight system, which includes a suspended tray that can carry up to 560 tons of ballast. And this allows the crane to maintain stability and lifting capacity even at long boom lengths and high angles. This crane made headlines in 2021 during its first major deployment in China's Gansu province, where it lifted and installed a 140-meter-high wind turbine that was a record for the country at the time. The operation required millimeter precision in high wind, and it was completed successfully within a tight schedule. Since then, it's been used across China's largest wind farms, including projects in Inner Mongolia and Hebei province. Its development was pretty significant too. It was a strategic industrial achievement. China had long aimed to reduce dependence on imported heavy machinery, and the XCA1600 is a clear step towards domestic self-sufficiency in that area. It shows that Chinese firms are now capable of designing and manufacturing ultra-heavy lifting equipment for the global market. With demand for taller wind turbines and modular megastructures continuing to grow, cranes like this one are likely to become even more essential. The balance of power, reach, and road mobility ensures it's going to remain a key player in the evolution of these large-scale constructions. Moving on to number 7, the ManTech RB293. Continuing the tradition of weird names, the ManTech RB293 is officially classified as a bucket wheel excavator, but the scale of this thing and integrated lifting system qualifies it as one of the largest crane-capable terrestrial vehicles. Manufactured in Germany by MAN and TechRaf, this massive machine operates in surface mining, and it's primarily used for removing overburden. It's best known for its size, and it weighs about 14,200 metric tons, making it one of the heaviest land vehicles ever constructed. It stands about 96 meters tall, it stretches 225 meters long, and operates on 12 crawler tracks. Now, while it's not a crane in the traditional sense, it does include multiple hoisting systems and cantilevered arms capable of manipulating equipment. Functionally, it resembles the duties of a mobile crane in the mining sector. One of its coolest features is the boom and counterweight system. This supports a massive rotating bucket wheel at the front of the machine. This thing is mounted on a massive cantilevered arm that can be raised or lowered and pivoted using hydraulic hoists and cables. This system allows for vertical and lateral movement of the heavy structural components, including parts of the excavator itself, to access platforms and occasionally external support equipment. The crane-like systems built into it are essential not only for the excavation, but also for maintenance and self-repair. The machine has several winch and derrick systems that can lift components like electric motors, hydraulic rams, and structural beams weighing up to 100 metric tons. These internal cranes eliminate the need for any separate heavy lifting equipment. Now, the machine operates at the Garzweiler surface mine in western Germany, where it moves tens of thousands of cubic meters of earth daily. The bucket wheel system rotates continuously while the vehicle crawls forward, removing overburden in long strips. The onboard control systems are supported by an extensive array of sensors and systems that monitor everything from ground pressure to component fatigue. Moving this thing is a pretty slow process. It travels at a maximum speed of 0.6 kilometers per hour and requires a coordinated operation of a crew of engineers, technicians, and operators, and the power is drawn from an external electric supply delivered through a high-voltage cable. While it wasn't designed with commercial crane work in mind, its lifting systems functionally perform many of the same tasks: the ability to lift, pivot, and position ultra-heavy components. No other machine of its type combines excavation and lifting at that scale. It is a machine that digs, lifts, repairs itself, and moves, slowly but surely, across one of the largest mines in Europe, quietly redefining the upper limits of land-based machinery. Number 6. The American 9299. The American Hoist and Derrick 9299, it's sometimes referred to as simply the American 9299, was the largest crawler crane in the world when it was first introduced in the late 1970s. Designed and built by American Hoist and Derrick Company, commonly known as AmHoist in St. Paul, Minnesota, this machine was an achievement in heavy lift engineering during a period when the global demand for industrial construction was rising. It had a lifting capacity of 1,200 metric tons, which was unprecedented for a crawler crane at the time. It was designed for use in refineries, power plants, and heavy civil engineering projects where large prefabricated modules needed to be lifted. With that modular construction, it could be dismantled and transported in segments, then reassembled on site. A key component of the design here was the lattice boom. It could be extended more than 122 meters, that's 400 feet, depending on the configuration. It was made of high tensile steel, designed for strength under vertical and torsional loading, and it also supported various jib attachments, which allowed it to achieve different boom configurations for specific lift types. Now, the crawler base of this thing was massive, using large steel tracks that allowed the crane to move, albeit slowly, across prepared surfaces on a job site. Once on site, setup could take weeks and involve bolting together huge structural components, including the hydraulic and control systems, and then testing all mechanical functions before use. This crane was used across the United States and internationally too. It was famously deployed in the construction of several major power plants and was involved in large-scale oil refinery expansions during the 1980s. Although only a limited number of units were built, the 9299 developed a reputation for rugged durability for its time. Over the years, newer cranes have surpassed it in lifting capacity and control systems, but it still holds an important place in crane history. It marked a transition from smaller, manually operated crawler cranes to super lift machines. As of the 2000s, most American 9299 cranes have been retired from active use, although some have been preserved or kept in limited service. They're occasionally referenced in heavy lift engineering literature as case studies in high-capacity, pre-digital crane design. It is a landmark in the development of crawler crane tech. Though it no longer represents the cutting edge, it did pave the way for machines that do, offering a real-world example of how ambition and industrial need combined to create one of the most powerful land-based cranes. Number 5. The Lamson LTL 3000. With such a catchy name like the Lamson Transilift LTL 3000, this thing is a hybrid crane that combines the benefits of a traditional crawler crane with the lifting power of a ring crane. It's manufactured by Lamson International. This is a Washington-based heavy lift contractor. This crane is one of the most adaptable lifting machines in the world, with a maximum capacity of 3,000 metric tons. Now, what sets this one apart is the modular design. It's mobile, too. Unlike fully fixed ring cranes or gantry system, the Transilift concept uses crawler tracks mounted on a modular ring support frame. This provides the stability of a ring crane with the flexibility of a crawler unit. The ring itself consists of curved steel track segments that can be transported, laid out on site, and connected to form a complete rotational base. The boom of it can be configured using lattice segments with available configurations that exceed 120 meters in length, depending on the requirements, and it can also support a luffing jib and superlift counterweight system, which can be mounted on trailing wagons for additional balance. Another major advantage of this crane is the low ground pressure, which is achieved through a combination of the ring base and the crawler tracks. This allows it to operate on surfaces that wouldn't support other cranes in its weight class, and that can be adapted for use on barges or floating platforms. The controls are fully digital, include real-time monitoring of load, wind, boom deflection, and hydraulic pressure, and Lamson also offers remote monitoring too and diagnostics through its support network, which allows for real-time troubleshooting. The LTL has been used in several high-profile projects, including the construction of nuclear reactors, petrochemical plants, and bridge segments. In one case, it was used to lift and place precast concrete bridge spans that weigh over 1,000 tons in a single piece. That's a task that would have required multiple cranes using traditional methods. Few cranes in the world can match the balance of power, precision, and flexibility offered by this one. It does represent the pinnacle of Transilift series, and it's a cornerstone of Lamson's international operations. Because it's both road transportable and capable of performing lifts once reserved for stationary giants, it's become a popular choice for contractors. It is a prime example of how hybrid crane design can meet evolving demands of modern infrastructure construction. Number 4. The Memoit SK350. Alright, Memoit showing us a better name. The Memoit SK350 is currently considered the strongest land-based crane in operation, capable of lifting up to 5,000 metric tons, placing it at the top of the global crane capacity rankings. The SK350 is part of Memoit's Strand Jack series of cranes. Each includes several models built for extreme scenarios. The SK350 was designed to meet increasing demands for modular construction, where large prefabricated components have to be lifted and installed. These include items like offshore oil rig modules, nuclear reactor components, petrochemical vessels, and wind turbine foundations. Now, what sets this one apart isn't just the lifting capacity, but its high hook height and long reach. The crane uses a ring-shaped base measuring about 55 meters in diameter, which allow it to rotate a full 360 degrees. This kind of base supports a massive boom and luffing jib, enabling it to lift extreme heights and radius. The crane uses a system of strand jacks. These are hydraulic devices that pull high-strength cables through a series of gripping mechanisms to hoist heavy loads. The use of these jacks also allows it to lift incrementally, maintaining control even when handling record-breaking weights. It's constructed from containerized components. That's where they can be shipped globally and assembled on site. That kind of flexibility makes the crane suitable for temporary deployments in remote or high-stakes environments. In 2021, it was deployed to the Middle East to support the construction of a massive modular gas treatment facility. There, it completed a series of heavy lifts involving pre-assembled process modules weighing over 3,000 tons. It is also capable of handling multiple lifts without needing repositioning. That's a critical advantage when working in tight or congested spaces. Only a very limited number of the SK350 cranes exists globally, and they're all operated under Memoit's direct control. This ensures consistency in operational standards, and it allows for a dedicated support infrastructure that can respond to a client's needs anywhere in the world. Its blend of raw capacity, modularity, and precision places it at the frontier of industrial construction technology, enabling projects that would otherwise be impossible due to scale or constraints. Number 3. The Husman Skyhook. The Husman Skyhook, that is a good name, is a giant offshore crane mounted on a semi-submersible vessel designed specifically for heavy lifting operations at sea. Built by Husman Equipment BV, a Dutch engineering company specializing in heavy construction, the Skyhook is a floating crane with a lifting capacity of 5,000 metric tons. What sets it apart is the integration with a semi-submersible platform. Now, this design allows for exceptional stability in rough oceans. That's a vital factor in offshore lifting ops. The semi-submersible hull minimizes the effects of any wave motion and current and provides a stable base from which to conduct precision lifting. The Skyhook's mast-type crane design features a fixed boom and a rotating superstructure. The lifting system includes high-capacity winches, dual-main hooks, and auxiliary hooks for smaller lifts. These operations are conducted either in single lift mode or through synchronized dual hook lifting. Its structure is mounted on the vessel's central deck, supported by a circular slew bearing that allows 360-degree rotation. This gives operators the flexibility to position heavy loads with accuracy even when environmental conditions change. Its boom length and lifting height vary by vessel, and most configurations support lift of over 100 meters high and boom outreach by about 80 meters. The Skyhook was developed to meet demands of deepwater oil and gas development. Its capabilities allow it to install remote massive modules directly from floating transport vessels. Now, one of its most notable features is the heavy compensation system, which adjusts automatically the load position in response to any wave motion. This system uses real-time motion data to modulate winch speed and tension, which keeps the hook steady even during moderate sea states. The Skyhook is capable of performing lifts safely and efficiently, retrieving heavy subsea structures and placing them onto barges for dismantling or even recycling. In addition to that fossil energy infrastructure, the Skyhook is increasingly being used in offshore wind farm construction, especially for the installation of monopile foundations and turbine components in deep water. Several versions of the Skyhook crane are in operation globally, mounted on specialized vessels managed by marine contractors, and each crane is custom-built for the vessel it supports. The Skyhook does represent a fusion of naval architecture and crane engineering. It enables operations that are both physically massive and environmentally sensitive. With ocean-based infrastructure becoming more ambitious in size and complexity, cranes like this one are central to building and maintaining the offshore economy. Number 1. Big Blue. Well, I guess we saved the best name for last, maybe? Big Blue? That's a good one. Is the nickname given to a massive crawler crane used in the construction of Miller Park, now American Family Field in Milwaukee, Wisconsin. Built by Lamson International, the crane was officially designated as a Transilift LTL 1500, capable of lifting over 1,200 metric tons. Although it was one of the most powerful cranes in the world at that time, Big Blue is most remembered for the tragic crane collapse that happened on July 14, 1999, during the stadium's construction. The crane had been brought in to lift and position massive roof sections, each weighing over 400 tons, as part of the retractable roof system being installed on the stadium. Its boom extended over 140 meters with a complex counterweight system that was mounted on a trailing wagon. The crane's setup was consistent with industry standards at the time, and the lift had been carefully engineered using load charts and weather models. However, conditions on the day of the lift proved to be unpredictable. During the lift of a 450-ton roof section, a sudden gust of wind, estimated at about 20 to 25 miles an hour, struck the boom while the load was suspended mid-air. The crane's boom buckled under the stress, causing it to collapse and drop the load. The accident killed 3 iron workers who were inside a suspended platform nearby. The event halted construction for over a year, and it triggered a detailed investigation by OSHA and engineering firms. The incident brought national attention to the risks of heavy lift operations, especially under variable weather conditions. The crane's design wasn't found to be inherently flawed. Rather, the failure was attributed to misjudgments in wind loading assumptions and lift planning under live site conditions. In the aftermath of the collapse, the damaged crane was removed from the site, and a redesigned lifting plan was created. Other, larger cranes, including another Lamson Transilift unit, were used to complete the roof installation, and new safety procedures were implemented, including stricter wind restrictions, dynamic load simulations, and real-time weather monitoring for any more heavy lift. Despite the tragedy, though, Big Blue is an important subject in engineering curricula and safety training. This collapse became a defining case study in the importance of real-world lift planning, and its lessons have influenced global crane safety standards ever since. The crane itself wasn't rebuilt. Instead, components were scrapped, and the name Big Blue became a lasting symbol of engineering ambition and the need for caution in high-risk construction environments. Today, the Miller Park crane collapse is one of the most well-documented crane accidents in history. Its legacy is complex. Big Blue was a technical marvel, capable of lifting more than most cranes in its class, but ultimately becoming a turning point in how engineers approach weather, wind, and lift planning. The event reshaped an entire industry's approach to risk, and it remains a critical reminder of the fine line between capability and failure in the world of giant crane vehicles.